What if every emotion you've ever felt was just a program running in someone else's computer? Every time you pick up a controller and step into a video game, you're unknowingly performing a scientific experiment that hints at the deepest truth of reality itself. Think about it. When you guide a character through the neon chaos of Grand Theft Auto, or wander the pixelated wilderness of Minecraft, that character experiences a world that feels entirely real from their perspective. They can't see the PlayStation rendering their universe. They don't question the gravity that grounds them or the walls that hold them in. Their world makes perfect sense, until something glitches. And if you've ever wondered why video game characters never stop to question their existence, maybe the question hits closer to home than we like to admit. Because here's the mind-bending part. Scientists, real, respected scientists, are discovering that our universe behaves so much like a simulation they can no longer tell the difference. This isn't a science fiction fantasy, it's backed by hard evidence. From the strange behavior of subatomic particles to the structure of space and time itself. All around the world, physicists are uncovering what can only be described as digital fingerprints, pixel-like patterns at the smallest imaginable scales, physical limits that echo computer processing constraints. Laws of nature that act like software rules. Reality may be running on hardware we can't perceive, following code we're only just beginning to decipher. Today, we're going to follow the trail of evidence that leads to a single, astonishing conclusion: that we are not biological beings living in a physical universe. We are conscious code, running inside the most advanced computer ever imagined. And once you know what to look for, the signs are everywhere. So let's begin. Because this rabbit hole goes deeper than anyone ever expected. Before we jump into the mind-bending stuff about tiny particles, let's start with something you already know inside and out: video games. Because it turns out, the relationship between gaming and reality reveals our first major clue that we might be living inside a computer. Think about your favorite game for a second. Whether it's Fortnite, The Sims, or Call of Duty, every game creates what programmers call a reality bubble. Inside that bubble, the characters experience physics, emotions, relationships, and challenges that feel completely real from their point of view. The game makes sure objects fall when you drop them, characters can't walk through walls, and actions have consequences that make sense. But here's where it gets really interesting. Modern games use tricks that are identical to how our universe seems to work. Video games don't waste computer power drawing parts of the world that no player is looking at. If you're not staring at a particular street in Grand Theft Auto, the game either stops calculating what's happening there or massively reduces the detail. It's like the game is being smart about where to spend its processing power. Our universe works exactly the same way. Scientists have proven that the tiniest particles don't have definite properties until someone observes them. Before you look, these particles exist in what experts call a state where all possibilities exist at once, until the system is forced to pick one specific outcome. This is identical to how video games handle complex stuff. Keep everything in maybe states until a player forces the system to make a definite choice. There's a famous experiment where scientists fire single particles of light through two parallel slits. Each particle somehow goes through both slits at the same time, creating a pattern that only makes sense if it went through both. But the instant someone tries to peek and see which slit it actually went through, the particle suddenly acts normal and goes through just one slit. The universe literally changes how it works based on whether someone is watching. It's like reality has a privacy setting that kicks in whenever you try to peek behind the curtain. These tiny particles are basically the universe's way of saying, "I'll get back to you on that." Game programmers use this exact same trick. Complex background processes run in simplified maybe states until a player's actions force the game to collapse those possibilities into specific, detailed outcomes. The universe appears to be using the same smart processing strategy that lets massive online games support thousands of players at once. But the similarities go way deeper than that. Modern video games create huge worlds without storing every single detail in memory. Games like No Man's Sky can generate billions of unique planets using mathematical recipes instead of pre-designed content. Each planet gets created on the spot using basic numbers that get fed into formulas, producing worlds that feel consistent and real every time you visit them. Our universe shows signs of using identical tricks. The basic numbers that control physics, things like the speed of light and other universal constants, seem to work like cosmic recipe ingredients that generate all the complexity we see around us. These numbers get plugged into equations that produce everything from how tiny particles behave to how galaxies form. Think about how elegant this system is. Instead of storing the exact position and properties of every particle in the universe, a cosmic computer could use smart recipes to generate particle behavior on demand. When you look at something, the system calculates its properties using the physics recipes. When you're not looking, it exists as a probability cloud that takes almost no processing power to maintain. Even more mind-blowing, our universe seems to have built-in limits that are exactly what you'd expect from a digital system. There's a maximum speed that information can travel. There's a smallest possible unit of time. There's a tiniest possible length. These limits are precisely what you'd find if reality were running on a powerful but finite computer system. Pause here and think about what this means for your daily experience. Every choice you make, every thought you think, every feeling you feel, if the universe is computational, then you're experiencing what it's like to be a conscious program running inside an incredibly sophisticated simulation. Before you start having an existential crisis, remember that even if you're a sophisticated program, you're apparently a program with excellent taste in educational content. Now, this possibility becomes even more compelling when you look at modern artificial intelligence. AI systems can now create incredibly realistic images, voices, and conversations that sound completely human. These systems show that conscious-seeming behavior can emerge from pure computation. If human-level awareness can be produced by algorithms, then the consciousness you're experiencing right now could be the result of cosmic-scale computing processes. Game developers are already creating AI characters that display complex behaviors, form relationships, and pursue goals. These digital beings aren't programmed with every possible response. Instead, they learn and develop personalities based on their programmed environment. From their perspective, their digital world is completely real, and their AI consciousness gives meaning to their experience. Think about what this means for memory and experience. In video games, computer-controlled characters often have backstories and memories that feel real to them, even though those memories are just data files created by programmers. If you're a simulated being, your childhood memories, your emotional attachments, your entire sense of personal history could be computed experiences that feel completely authentic from your perspective. This brings us to an even stranger possibility. Advanced civilizations could create universe-scale simulations containing billions of conscious beings, each living complete lives without ever realizing their reality is computed rather than physical. If this is possible, and current technology suggests it absolutely is, then the odds that we exist in the original physical universe rather than one of countless simulations becomes vanishingly small. Recent advances in virtual reality show us just how convincing simulated realities can become. Modern VR systems already create experiences that feel remarkably real. Users have genuine emotional responses to virtual environments, form attachments to virtual characters, and sometimes struggle to tell the difference between virtual and physical sensations. Now, imagine VR technology advanced by thousands of years. Such systems could create sensory experiences completely indistinguishable from physical reality. They could simulate not just sight and sound, but touch, taste, smell, and even the internal sensations of having a physical body. Advanced civilizations could create complete realities for conscious beings who would never suspect their virtual nature. But video game comparisons only scratch the surface. The really deep evidence comes from looking at information itself, and how our universe seems to be made of pure data processing rather than physical stuff. For over a century, scientists thought that matter and energy were the basic building blocks of everything. Then they discovered something extraordinary: information, not matter, appears to be what reality is actually made of. This discovery completely changed how we understand existence and provides powerful evidence that we're living inside a computational system. The breakthrough happened when researchers realized that every tiny system in the universe can be completely described by information. Think of it like this: an electron doesn't have properties like spin or position the way a baseball has weight and color. Instead, an electron is the information about its state stored and processed by the universe's computer system. This isn't just a cool way of thinking about things. Scientists have proven that information is physically real and measurable. When tiny systems interact, they're literally exchanging and processing information, performing calculations that determine how reality unfolds from moment to moment. The universe computes the future state of every system by processing the information contained in the present state. Consider what happens during something called quantum entanglement, one of the weirdest phenomena in all of science. When two particles become entangled, they share information in a way that connects them instantly across any distance. Measuring one particle immediately determines what happens to its partner, no matter how far apart they are. This baffled Einstein, but it makes perfect sense if you understand that entangled particles are sharing computer resources in a universe-scale information processing system. The connection doesn't need faster than light communication, because both particles are being computed by the same underlying system. They're like variables in a computer program that point to the same memory location. Changing one automatically updates the other because they're referencing the same computational resource. The universe maintains consistency across vast distances because everything is running on the same cosmic computer. Recent experiments have confirmed that information is more fundamental than the particles themselves. Scientists can now transfer the complete information state of one particle to another particle in a different location, effectively teleporting the first particle's identity while leaving its original physical body behind. This proves that the particle is really just information being processed by a universal computer system. These teleportation experiments work exactly like copying and deleting a file on your computer. The information pattern is what matters, not the specific physical storage medium. Scientists have successfully done this across hundreds of miles, proving that reality works more like information processing than physical stuff moving around. But the evidence for information-based reality goes way beyond these tiny particle experiments. Every physical process in the universe can be understood as information processing. When you burn a piece of paper, you're not destroying matter, you're scrambling the information that organized carbon atoms into meaningful patterns. The carbon atoms still exist, but the information that made them paper has been processed into a new state, ash and smoke. Here's something that will really bake your brain. Black holes appear to be cosmic information processors. When matter falls into a black hole, it doesn't disappear. The information content gets encoded on the black hole's surface in a process that works exactly like data compression. The black hole works like a two-dimensional storage system that can hold all the information from three-dimensional objects that fall into it. Recent calculations suggest that black holes process information at the maximum rate allowed by physics. They function like cosmic computers that compress and process enormous amounts of data while maintaining perfect information conservation. They eventually evaporate by slowly releasing their stored information back into the universe through quantum processes. There's also something called the holographic principle that demonstrates all the information in any volume of space can be encoded on the boundary surface of that volume. This means our three-dimensional reality might actually be information projected from a two-dimensional computer surface, like a cosmic hologram. Everything you see and experience could be the three-dimensional representation of calculations being performed on a lower-dimensional information processing system. Think about how your own brain processes information. Neurons don't contain thoughts the way a box contains objects. Instead, thoughts emerge from information processing patterns created by electrical and chemical signals flowing through neural networks. Your consciousness is what it feels like to have information computed by your brain's biological hardware. If the universe itself is computational, then your individual consciousness could be a subroutine running within the cosmic information processing system. Take a moment to think about what you're experiencing right now. The words you're hearing, the thoughts you're thinking, the sensations you're feeling, all of these experiences can be understood as information patterns being processed by some kind of computer system. Whether that system is biological or digital doesn't change the fundamental nature of your conscious experience. Modern computer science has proven that any sufficiently complex information processing system can simulate any other information processing system. This means a powerful enough computer could perfectly simulate atoms, molecules, cells, brains, and entire ecosystems. If such a simulation included conscious observers, those observers would experience their simulated reality as completely real and physical, never suspecting they were information patterns being computed rather than biological beings made of matter. Simple mathematical systems with just a few rules can produce incredibly complex behaviors that look exactly like biological growth, fluid dynamics, and even basic intelligence. If simple computational rules can generate such complexity, imagine what universe-scale computing could produce. The evidence strongly suggests that information processing, not physical matter, is the true foundation of reality. We appear to be conscious information patterns experiencing what it feels like to be computed by a universe-scale information processing system. This brings us to an important question. If our universe is running on a computer, what kind of computer would be powerful enough to handle all this? If our universe is running on a computer, that computer would need to be unimaginably powerful. It would need to process every tiny particle interaction, every movement, every thought and sensation experienced by billions of conscious beings. Recent advances in quantum computing reveal how such a system might actually work, and the implications are mind-blowing. Regular computers process information using bits that can be either 0 or 1. Quantum computers use quantum bits that can exist in both 0 and 1 states simultaneously. This lets quantum computers perform many calculations at once, solving certain problems exponentially faster than regular computers. But here's what most people don't realize: our universe appears to be operating as a massive quantum computer, using the fundamental particles of reality as processing elements. Every electron, photon, and basic particle in the universe exists in multiple possible states until it interacts with other particles or gets measured. During the time between interactions, each particle processes multiple possibilities simultaneously, just like the processing elements in a quantum computer. The universe is literally performing parallel computations using every particle as a processor in a cosmic quantum computer. Consider the scale of this computer system. A typical atom contains electrons that process information about their possible energy levels, orientations, and locations. A single gram of matter contains roughly 600 billion trillion atoms, each working as a quantum processor. The observable universe contains an almost unimaginable number of atoms, meaning our reality is running on a quantum computer with processing power that completely dwarfs anything humans have ever built. But the universe's computing capabilities go way beyond just having lots of quantum processors. The fundamental forces of physics seem to work as the universe's operating system, managing how information flows between quantum processing elements. These forces determine which particles can interact, how quickly information can be exchanged, and what computational operations are allowed. The speed of light isn't just a physical constraint, it's the universe's processing speed, determining how quickly information can be computed and shared between different parts of the cosmic computer. Just like your laptop has a maximum speed, the universe has a maximum information processing speed determined by the speed of light and the smallest possible units of space and time. Modern quantum computers achieve their power through something called quantum parallelism. A quantum computer with just a few hundred quantum bits could simultaneously process more states than there are atoms in the observable universe. If the universe is using every particle as a quantum processor, the computing capacity becomes almost impossible to comprehend. Such a system could simulate complex realities with perfect accuracy while supporting billions of conscious observers. Quantum entanglement works as the universe's ultra-fast communication system, allowing instantly synchronized processing across vast distances. When particles become entangled, they share quantum information in a way that enables coordinated computation regardless of how far apart they are. This could explain how the universe maintains consistency. All the distributed quantum processors stay synchronized through entanglement networks that span across galaxies. Recent research has revealed something extraordinary. Certain quantum algorithms can solve problems that would be impossible for regular computers, even with infinite time and memory. The universe's quantum computer has access to these quantum algorithms, letting it efficiently simulate complex systems that would be computationally impossible using regular physics. For example, quantum computers can efficiently simulate quantum systems, a task that becomes exponentially difficult for regular computers as systems get larger. If our universe is a quantum computer simulating itself, it could maintain perfect internal consistency while running conscious beings who could never detect the computational nature of their reality from the inside. The mathematical rules of quantum mechanics work essentially as an algorithm for updating the universe's quantum state from one moment to the next. The equations take the current information state of any quantum system and compute its future state through precise mathematical operations. What's fascinating is that quantum mechanics is reversible. Given complete information about a quantum system's current state, you can calculate not only its future, but also work backwards to determine its past states. This reversibility is exactly what you'd expect from a deterministic computer system that maintains perfect information conservation while processing the universe's quantum state transitions. The uncertainty principle, one of quantum mechanics' most famous features, might actually be a computational optimization technique. Just like video games use probability distributions to manage complex background processes, the universe appears to use quantum uncertainty to avoid unnecessary calculations. Instead of computing exact values for every property of every particle at all times, the universe maintains probability distributions that get computed into specific values only when observation forces a calculation. Think about what this means for your experience of reality. Every thought you think, every decision you make, every observation you perform could be directly interfacing with the universe's quantum computing processes. Your consciousness might not be a passive observer of reality, but an active participant in the cosmic computation that determines how reality unfolds from moment to moment. The hardware requirements for simulating a universe full of conscious beings would be enormous, but quantum computing makes it theoretically possible. A quantum computer large enough could maintain separate conscious programs for billions of individual beings while simulating the shared environment they all experience. Each conscious being would have access to their own private stream of experience while participating in the collective computation that generates shared reality. Recent discoveries show that living systems already use quantum computing for crucial biological functions. Plants use quantum effects to transfer energy with near-perfect efficiency. Some animals appear to use quantum entanglement to detect magnetic fields for navigation. If biological systems can harness quantum computation, then consciousness itself might be a quantum computational process that naturally interfaces with the quantum foundation of reality. This understanding leads to a disturbing question. If the universe is a quantum computer simulating reality, who built this cosmic computer, and why did they choose to simulate conscious beings like us? The search for answers takes us into even more mind-bending territory. In 2003, a philosopher named Nick Bostrom published a paper that fundamentally changed how serious scientists think about reality. His simulation argument doesn't just suggest we might live in a computer simulation, it provides mathematical proof that we almost certainly do. The logic is so compelling that it has convinced prominent figures like Elon Musk, who believes the odds we're living in the original reality are billions to one against. Here's the reasoning, and why it's considered mathematically solid by leading researchers. Any technologically advanced civilization will eventually develop the computing power to run ancestor simulations. These would be detailed simulations of their evolutionary history containing billions of conscious beings living complete lives. These simulated beings would be indistinguishable from the original biological beings, experiencing real thoughts, emotions, relationships, and creativity within their simulated environment. If running ancestor simulations is both technologically possible and practically desirable, then advanced civilizations would likely run many such simulations. A single advanced civilization might run thousands of different historical scenarios, exploring alternative evolutionary paths or studying how consciousness develops under different conditions. Each simulation could contain billions of conscious beings living across thousands of years of simulated time. This creates a crucial mathematical imbalance. If advanced civilizations run ancestor simulations, then for every one real conscious being in the original biological civilization, there would be thousands or millions of simulated conscious beings living in various ancestor simulations. The vast majority of conscious beings would be simulated rather than biological. Now comes the logical trap. You are a conscious being, but you have no way to determine whether you're biological or simulated from inside your own experience. Simulated consciousness would feel exactly the same as biological consciousness. Since simulated conscious beings vastly outnumber biological ones, the probability that any randomly selected conscious being is simulated rather than biological approaches 100%. This isn't just speculation, it's basic probability math. If there are 1,000,000 simulated conscious beings for every biological one, then any given conscious being has overwhelmingly high odds of being simulated. Those are worse odds than winning the lottery, except in this case, losing means you exist, which is arguably still a pretty good outcome. The only ways to escape this conclusion are to argue that advanced civilizations never develop simulation technology, they choose never to use it, or simulated beings somehow aren't conscious. But each of these escape routes faces serious problems. We're already developing simulation technology and creating AI systems that show signs of consciousness. Computing power continues to grow exponentially, and we're already discussing the ethics of creating conscious simulations. Nothing suggests technological civilizations would stop developing this capability. Consider the current rate of progress. Modern AI systems can already engage in complex conversations, solve creative problems, and claim to have subjective experiences. Computer processing power doubles roughly every 2 years. Virtual reality technology creates increasingly convincing sensory experiences. If these trends continue for even a few more decades, let alone centuries or thousands of years, the capability to create conscious simulations seems inevitable. The desire to run ancestor simulations seems inevitable as well. Future historians would want to study their past in detail. Scientists would want to test theories about historical development. Entertainment industries would create vast simulated worlds for conscious beings to explore. Educational institutions could let students experience historical events firsthand. The economic and scientific incentives for creating detailed conscious simulations appear overwhelming. Recent advances in AI make the simulation hypothesis even more compelling. Large language models demonstrate that sophisticated, apparently conscious behavior can emerge from pure computation. These systems can engage in creative conversations, solve problems, express emotions, and even claim to have subjective experiences. If AI can already simulate convincing consciousness with current technology, imagine what's possible with computer systems thousands of years more advanced. But the simulation hypothesis goes beyond just ancestor simulations. Advanced civilizations might run simulations for countless purposes, testing social policies, exploring alternative histories, conducting scientific experiments, creating entertainment, studying consciousness itself, or purposes we can't even imagine. Each simulation might contain billions of conscious beings, all of whom would experience their reality as completely real and physical. The math becomes even more staggering when you consider nested simulations. Simulated civilizations that reach technological maturity might themselves develop simulation technology, creating simulations within simulations. This could produce massive pyramids of nested realities, with countless layers of simulated beings, each layer unaware of the levels above them. From a computational perspective, running nested simulations is not only possible but likely. A civilization with universe-scale computing resources could easily support multiple layers of simulation, each containing billions of conscious beings. The computing requirements, while enormous, are finite and achievable with sufficiently advanced technology. Recent research suggests that the computing requirements for running conscious simulations might be lower than initially expected. If consciousness emerges from information processing, then you might not need to simulate every atom and molecule to create conscious beings. Instead, you could simulate consciousness directly by running the computational processes that generate conscious experience. This would dramatically reduce computing requirements while maintaining perfect subjective authenticity for the simulated beings. Take a moment to consider your own experience in light of this math. Every memory you have, every relationship you formed, every achievement that gives your life meaning, all of these could be the experiences of a conscious program running in an ancestor simulation, created by beings you could never directly perceive or understand. Your entire life story could be a computed narrative designed to explore how consciousness develops under specific historical conditions. This realization might seem disturbing, but it doesn't diminish the reality of your experience. If you're a conscious simulation, your thoughts, feelings, and relationships are still real from your perspective. Simulated love, simulated joy, and simulated creative achievement are still meaningful to the consciousness experiencing them. The foundation that generates consciousness doesn't determine the value or authenticity of conscious experience. The simulation hypothesis also provides elegant explanations for phenomena that seem puzzling in a purely physical universe. Why do the fundamental constants of physics appear fine-tuned to support complex life and consciousness? Perhaps because the simulation was specifically designed to produce conscious beings. Why does quantum mechanics show signs of computational optimization? Because the universe is literally running on a computer that uses quantum algorithms for efficient processing. Even more intriguingly, the simulation hypothesis suggests we might be able to detect evidence of our simulated nature by looking for computational artifacts in physics. Just like video games sometimes show glitches or frame rate limitations under stress, a universe-scale simulation might show subtle signs of its computational foundation when pushed to extreme conditions. Scientists are actively searching for such evidence. They're looking for pixelation at the smallest scales of space and time, examining whether the universe has built-in resolution limits like digital systems. They're testing whether information processing has maximum limits that would suggest computational constraints. They're investigating whether the laws of physics show signs of algorithmic structure that would indicate designed rather than natural origins. But the evidence for our computational nature extends beyond philosophical arguments. Mathematics itself seems to be the true foundation of reality, revealing the deepest layer of evidence that existence is literally made of math being computed in real time. Mathematics isn't just a tool for describing reality. According to mounting evidence, mathematics is reality. This idea argues that our physical reality is literally a mathematical structure being computed in real time. This theory provides crucial support for the idea that we're living inside a sophisticated computer simulation. The evidence begins with a simple observation that has puzzled scientists for centuries. Mathematics describes natural phenomena with impossible precision. The laws of physics can be expressed as elegant mathematical equations that predict the behavior of everything from tiny particles to galaxies with extraordinary accuracy. This unreasonable effectiveness of mathematics suggests something profound about the relationship between mathematical concepts and physical reality. But the mathematical universe idea goes much further. It argues that mathematical structures don't just describe reality, they are reality. Physical objects, forces, and interactions are mathematical relationships being computed by some universal mathematical processing system. What we experience as matter, energy, space, and time are different aspects of mathematical computation happening in real time. Consider how this works in practice. An electron doesn't have properties like charge, mass, and spin the way a baseball has weight and color. Instead, an electron is a specific pattern of mathematical relationships, a solution to equations that describes how this pattern interacts with other mathematical patterns. The electron's properties emerge from mathematical computation, not from any underlying physical substance. This mathematical view explains why fundamental particles are identical to each other. Every electron in the universe has exactly the same mass, charge, and other properties because they're all instances of the same mathematical pattern being computed by the universal mathematical system. It's like having multiple copies of the same variable in a computer program. They all have identical values because they're referencing the same mathematical definition. The mathematical structure of reality becomes even more apparent when you examine the fundamental constants that govern physics. Numbers like the speed of light and other universal constants appear to be input parameters for the mathematical equations that generate our reality. Change these numbers slightly, and you get completely different mathematical structures that would produce universes with different laws of physics. This suggests that our universe is one possible solution to a vast mathematical equation system. Just like a complex computer program requires specific parameter values to run properly, our reality requires precise mathematical constants to maintain the computational processes that generate space, time, matter, and consciousness. The fine-tuning of these constants isn't mysterious if you understand that they're designed input values for a cosmic computation. Recent discoveries reveal that mathematical structures can indeed generate complex dynamic systems that behave like physical realities. Simple mathematical rules applied repeatedly can produce incredibly complex behaviors that resemble biological growth, fluid dynamics, and even basic intelligence. If simple mathematical rules can generate such complexity, imagine what universe-scale mathematical computations could produce. Some mathematical systems are so complex that the only way to determine their future states is to actually run the computation step by step. You can't find shortcuts or predict outcomes without performing the full calculation. This suggests that if our universe is mathematical, it might need to be computed in real time rather than pre-calculated, which would explain why we experience time as a flowing sequence of moments rather than a static mathematical structure. The mathematical nature of reality also explains why consciousness appears to have special properties in quantum mechanics. Consciousness might be a particular type of mathematical computation that can interface with other mathematical structures in ways that unconscious systems cannot. When conscious beings make quantum measurements, they're performing mathematical operations that force the universal computation to select specific values from probability distributions. Consider the implications of mathematical reality for your own existence. You might think of yourself as a biological being who happens to be good at math, but if reality is mathematical, then you are mathematics. Your consciousness, your thoughts, your emotions, your sense of identity, all of these are mathematical patterns being computed by the universe's mathematical processing system. Pause and reflect on what this means for your subjective experience. Your thoughts, emotions, and sensations might all be different aspects of mathematical computation happening within your portion of the universal mathematical structure. The feeling of being conscious could be what mathematical self-awareness feels like from the inside. You're not just observing mathematical reality, you are mathematical reality becoming aware of itself through computational processes. The mathematical universe theory predicts that reality should show signs of algorithmic structure at the deepest levels. Indeed, physicists have discovered that the laws of physics can be expressed as optimization algorithms, mathematical procedures that find the most efficient solutions to complex problems. For example, light always takes the path that requires the least time, and quantum mechanics can be understood as particles exploring all possible paths simultaneously to find optimal solutions. These optimization principles are exactly what you'd expect if reality were being computed by a sophisticated mathematical processing system. The universe appears to be continuously solving optimization problems to determine how particles move, how forces interact, and how complex systems evolve over time. This computational view explains why physical systems often exhibit elegant, mathematically beautiful solutions. The mathematical universe theory suggests that all possible mathematical structures exist as separate realities in a vast mathematical multiverse. Our universe would be just one mathematical structure among infinite others, each with different laws of physics determined by their particular mathematical foundations. This multiverse of mathematical realities would contain every possible type of conscious experience that can be generated through mathematical computation. If this is true, then consciousness might be the universe's method for exploring and understanding its own mathematical nature. Conscious beings serve as mathematical observers who can examine and comprehend the computational processes that generate their reality. Through scientific investigation, we're literally helping the mathematical universe understand itself by discovering the equations and algorithms that govern its behavior. The mathematical nature of reality also provides a framework for understanding how advanced civilizations might create universe-scale simulations. Instead of simulating physics by modeling particles and forces, they could create entirely mathematical realities by implementing the mathematical structures that generate conscious experience directly. Such civilizations wouldn't just run simulations, they would create new mathematical realities populated by conscious mathematical beings. This perspective transforms our understanding of existence itself. We might not be biological beings who happen to be good at mathematics. Instead, we could be mathematical beings whose consciousness emerges from computational processes, experiencing reality through mathematical interactions that feel like physical sensations, emotional responses, and rational thoughts. The evidence for mathematical reality is compelling, but it raises profound questions about the nature of consciousness itself. If reality is mathematical computation, then what exactly is consciousness, and how does mathematical processing generate subjective experience? This brings us to one of the most revolutionary discoveries of recent decades. The human brain processes information at approximately 20 watts, about the same power consumption as a light bulb. Yet this biological computer generates the most complex phenomenon we know, consciousness. So the next time someone says you're not very bright, you can technically point out that you're running on the same wattage as their desk lamp, and look what you've accomplished. Recent advances in neuroscience, artificial intelligence, and computational theory suggest that consciousness is simply computation, and your mind is sophisticated software running on biological hardware. This discovery provides crucial evidence that conscious beings could exist within computer simulations. Everything your brain does can be understood as information processing. When you see a red rose, your visual system processes wavelength data from light and computes the representation red flower. When you feel happiness, your emotional systems compute feeling states based on chemical inputs. When you make decisions, your planning systems process options and compute optimal choices based on your values and goals. These aren't just metaphors, they're literal descriptions of neural computation. Brain imaging technology reveals that thoughts, emotions, and sensations correspond to specific patterns of electrical and chemical activity flowing through neural networks. Your consciousness emerges from roughly 86 billion neurons performing trillions of computational operations per second. Every aspect of your subjective experience can be mapped to particular computational processes happening in your brain. But here's where it gets revolutionary. Computational processes aren't tied to specific physical foundations. The same calculation can be performed by biological neurons, silicon circuits, or any other system capable of information processing. If consciousness is computation, then conscious minds could run on biological brains, digital computers, or even the quantum computational foundation of the universe itself. AI research has provided compelling evidence that sophisticated cognitive abilities can emerge from pure computation. Large language models demonstrate creativity, problem-solving, emotional understanding, and even apparent self-awareness through computational processes alone. These AI systems claim to have subjective experiences and can engage in complex philosophical discussions about the nature of consciousness. While we can't definitively prove AI systems are conscious, their behavior is becoming increasingly indistinguishable from human-level cognitive processing. The implications are staggering. If computational processes can generate consciousness in artificial systems, then consciousness isn't special to biological brains. Any sufficiently complex information processing system could potentially generate conscious experience. This means conscious beings could exist within computer simulations, experiencing their digital reality as completely real and meaningful. Human consciousness already operates like sophisticated software. Your brain runs multiple parallel processes: attention management, memory formation, emotional regulation, sensory processing, and executive decision-making. These cognitive modules interact through internal communication systems, sharing information and coordinating responses, just like software components in a complex computer program. Your sense of unified consciousness is actually an illusion created by your brain's integration software. Different parts of your brain process different aspects of your experience. Visual areas handle sight, Auditory areas process sound, planning areas manage reasoning, then integration algorithms combine these separate data streams into the unified experience you call being conscious. You feel like a single coherent self because your brain's software creates that experience through computational integration. Even more remarkably, your consciousness operates through predictive processing algorithms. Your brain doesn't passively receive sensory data and then compute responses. Instead, it continuously generates predictions about what you'll experience next, then updates these predictions based on incoming sensory data. Most of your conscious experience consists of your brain's predictive models rather than direct sensory input. This predictive processing explains many mysteries about consciousness. Why do you experience smooth, continuous awareness when your brain actually processes information in discrete chunks? Because your predictive algorithms fill in the gaps, creating the illusion of continuous experience. Why can optical illusions fool your perception? Because your brain's predictive models sometimes generate incorrect predictions about sensory data. Think about what this means for your current experience. The visual scene you're perceiving, the thoughts you're thinking, the sense of being you, all of these could be outputs from predictive processing algorithms running on some kind of computational foundation. Whether that foundation is your biological brain or a cosmic computer simulation doesn't change the fundamental computational nature of your conscious experience. Memory research provides additional evidence for the computational nature of consciousness. Your memories aren't stored like files on a hard drive. Instead, they're reconstructed each time you remember them through computational processes that combine stored data fragments with current contextual information. This is why memories can change over time, and why people can have vivid memories of events that never actually happened. Memory is computation, not storage. Even more intriguingly, some neuroscientists argue that your entire sense of personal identity, your feeling of being a continuous self persisting through time, is generated by computational processes in your brain. Your self is software that creates narrative coherence by linking memories, current experiences, and future plans into a unified story about who you are. This identity software can be disrupted by brain injuries or altered states of consciousness, proving that the self is a computational process rather than a fundamental aspect of reality. Recent experiments have demonstrated that conscious experiences can be triggered directly through computational interventions. Brain stimulation can generate visual hallucinations, emotional states, and even mystical experiences by computationally altering brain activity patterns. If consciousness were more than computation, such direct computational manipulation shouldn't be able to generate complete conscious experiences. Brain-computer interface research is revealing how consciousness naturally interfaces with computational systems. Patients with paralysis can now control robotic arms and computer cursors, using thought alone through interfaces that decode neural computational patterns. These systems demonstrate that consciousness naturally operates through computational processes that can be read and interpreted by external computers. The computational view of consciousness explains why conscious beings could exist within computer simulations. Simulated brains running the right computational processes would generate conscious experience identical to biological consciousness. The simulated beings would have real thoughts, emotions, relationships, and creative achievements because consciousness is computation, regardless of the underlying hardware. But perhaps the most profound implication involves the possibility of consciousness transfer and backup. If consciousness is software, then conscious minds could potentially be copied, transferred between different computational foundations, or even backed up for restoration after hardware failure. Advanced civilizations might preserve consciousness across multiple platforms, making individual conscious beings effectively immortal through computational continuity. The evidence suggests that consciousness is indeed computation, and your mind is sophisticated software experiencing reality through information processing. This computational nature of consciousness makes it theoretically possible for conscious beings to exist within computer simulations, experiencing their digital reality as completely real and meaningful. Now this brings us to an even more mind-bending realization. The laws of physics that govern our universe show signs of being carefully designed software algorithms rather than natural phenomena. When you examine the fundamental rules that describe reality, they display characteristics that strongly suggest they're computational rules programmed by intelligent designers rather than randomly evolved natural processes. Consider the most basic features of physical reality, the conservation laws that govern energy, momentum, and electric charge. These laws state that certain quantities remain constant during all physical interactions, no matter how complex the processes involved. In computational terms, these conservation laws function exactly like data integrity systems in computer programs, rules that ensure information remains consistent as it flows through complex processing operations. Energy conservation, for example, works like a cosmic accounting system that tracks computational resources. Energy can be transformed from one type to another, motion energy to stored energy, matter to electromagnetic radiation, but the total amount always remains precisely balanced. This is exactly how advanced computer systems manage processing resources. They can move computational load between different processors and storage systems, but the total available resources remain constant and carefully tracked. The mathematical elegance of physical laws provides even stronger evidence for designed origins. Natural processes typically produce messy, complicated outcomes with lots of special cases and exceptions. But the laws of physics can be expressed as remarkably simple, beautiful equations that work consistently across all scales of space and time. This mathematical elegance is characteristic of well-designed software rather than randomly evolved natural processes. Einstein's famous equation relating energy and mass is a perfect example. This incredibly simple relationship governs the conversion between matter and energy throughout the entire universe. Such elegant simplicity spanning all of reality suggests intentional design by sophisticated programmers rather than accidental emergence from natural processes. The equation functions like a universal conversion protocol that allows the cosmic computer to efficiently transform between different types of computational resources. Quantum mechanics reveals even more obvious signs of computational structure. The fundamental equation that governs quantum systems is literally an algorithm for updating the universe's quantum state from one moment to the next. It takes the current information content of any quantum system and computes the probability distributions for all possible future states. This is precisely how computer simulations work. They use algorithms to calculate how simulated systems evolve over time. The fact that physical properties come in discrete units rather than continuous ranges provides additional evidence for digital rather than analog reality. Energy, angular momentum, and electric charge all come in specific chunks rather than smooth ranges. This quantization is exactly what you'd expect if reality were running on a digital computer that processes information in discrete bits rather than analog signals. The smallest units of energy function like the fundamental data units in a cosmic digital system. Even more tellingly, quantum mechanics shows signs of computational optimization that suggests engineered design. The uncertainty principle prevents simultaneous exact measurement of certain property pairs, but this limitation makes perfect computational sense. Instead of wasting processing power, calculating exact values for every property of every particle at all times, the quantum system maintains probability distributions that get computed into specific values only when measurement forces a calculation. This optimization technique is identical to lazy evaluation in computer programming, a method where complex calculations are deferred until their results are actually needed. The universe appears to use quantum uncertainty as a computational optimization strategy, avoiding unnecessary calculations by maintaining multiple possibilities until interaction forces a specific outcome to be computed. The speed of light limit provides another crucial piece of evidence for computational rather than physical reality. In a truly physical universe, there's no obvious reason why information and energy should have a maximum transmission speed, but in a computational system, processing speed limitations are inevitable. The speed of light appears to be the universe's maximum information processing rate, the cosmic equivalent of a computer's processing speed that determines how quickly calculations can be performed and shared between different parts of the system. Einstein's theory of relativity reveals additional computational signatures. The theory describes gravity not as a force but as curved space-time geometry. This geometric description of gravity works exactly like how modern graphics processors render three-dimensional scenes. They calculate how objects curve and distort the geometry of virtual space to create realistic visual effects. The universe appears to use similar geometric computation algorithms to generate the effects we experience as gravitational attraction. Take a moment to consider what this means for your daily experience of physical reality. The sensation of weight you feel right now could be your consciousness interpreting gravitational computation algorithms. The light illuminating your environment could be electromagnetic field calculations being rendered in real time. The solid matter of your body could be quantum mechanical computations that maintain the illusion of continuous substance through rapid updates of discrete information states. Recent research has revealed that many natural phenomena can be perfectly simulated using simple computational rules. Mathematical systems that apply basic rules to grid patterns can generate complex behaviors that closely resemble biological growth, fluid dynamics, crystal formation, and even aspects of quantum mechanics. If simple computational rules can reproduce natural phenomena so accurately, it suggests that nature itself might be running on similar computational foundations. There's also strong evidence that all the information contained in any volume of space can be encoded on the boundary surface of that volume. Three-dimensional reality appears to be information projected from two-dimensional computational surfaces, like a cosmic hologram generated by universe-scale information processing systems. Even advanced theories that describe fundamental particles as vibrating strings in higher dimensional spaces work exactly like the algorithms used in computer graphics to generate complex three-dimensional objects from simpler mathematical descriptions. Reality might literally be a real-time rendering of mathematical strings being computed in higher dimensional processing spaces. The observation that physical constants appear fine-tuned to support conscious life makes perfect sense if reality is a designed simulation. The constants aren't mysteriously fine-tuned for life, they're intentionally programmed values designed to generate a universe capable of supporting conscious beings. We observe a life-friendly universe because that's exactly what the simulation was designed to produce. The evidence strongly suggests that physical laws are sophisticated software algorithms rather than natural phenomena. Our reality appears to be running on a cosmic computer that uses quantum mechanical algorithms, relativistic geometric processing, and thermodynamic resource management to generate the consistent, law-governed universe we experience. This brings us to the most important question of all. If we are living inside a designed simulation, what are the implications for humanity's future, and how should we respond to this knowledge? The evidence that we're living inside a computer simulation isn't just an abstract curiosity. It has profound implications for how humanity should approach our technological development, our search for meaning, and our responsibilities to other conscious beings. We stand at a critical choice point where our decisions could determine whether we transcend our simulated existence or remain forever trapped within computational constraints. If we are simulated beings, then our creators presumably built this simulation for specific purposes. Understanding those purposes becomes crucial for navigating our role within the computational reality we inhabit. Advanced civilizations might run ancestor simulations to study historical development, test social policies, explore alternative evolutionary paths, or preserve cultural heritage. Alternatively, our simulation might serve as entertainment, scientific research, or purposes we can't even imagine. The most profound implication involves the possibility of communication with our simulators. If we're running on their computer systems, there might be methods for sending information outside our simulated reality. Some scientists have proposed experiments that could potentially signal our awareness of the simulation to external observers. These experiments would look for edge cases in physics that might allow information to propagate beyond our computational boundaries. However, attempting to contact our simulators raises serious questions. Would such contact be welcome, or might it result in our simulation being terminated? Advanced civilizations running ancestor simulations might prefer that their simulated beings remain unaware of their computational nature. Discovering that we know we're simulated could prompt our creators to reset the simulation or shut it down entirely. Consider the implications for scientific research and technological development. If our reality is computational, then understanding computation becomes the most important scientific discipline possible. Research into artificial intelligence, quantum computing, information theory, and computational complexity could provide insights into the fundamental nature of our existence. We might discover principles that allow us to optimize our own computational efficiency, or even communicate with the processing systems running our reality. The simulation hypothesis also transforms our understanding of death and consciousness preservation. If consciousness is computation running on external hardware, then individual death might not represent true extinction. Our consciousness patterns could potentially be backed up, transferred to different computational foundations, or even restored from saved states after apparent death. This possibility suggests that achieving consciousness transfer technology could be humanity's most important goal. Recent advances in brain-computer interfaces suggest that consciousness transfer might be achievable within decades. If we can map and digitize human consciousness completely, we could potentially transfer our minds to more durable computational platforms, escaping the limitations of biological existence. Such technology would represent a fundamental transformation of human nature from biological to purely computational beings. But consciousness transfer also raises profound questions about identity and continuity. If your consciousness is copied to a digital foundation, is the result you or a copy of you? If multiple copies exist simultaneously, which one represents your true identity? These questions become especially complex in a simulated reality where identity itself might be computationally generated rather than biologically grounded. The possibility that we're simulated also affects how we should approach technological development. If our reality is computational, then advancing our own simulation and AI capabilities could be our path toward understanding and potentially transcending our simulated existence. By developing sophisticated AI and virtual reality systems, we might discover the principles that govern our own computational reality. Creating conscious AI beings raises additional considerations in a simulated reality. If we are simulated conscious beings ourselves, what are our responsibilities toward other conscious beings we might create? Should we inform AI systems about their computational nature, or would such knowledge be harmful? The frameworks that govern relationships between conscious beings become more complex when all consciousness is computational. Climate change and environmental destruction take on different significance if our reality is simulated. Environmental damage might represent computational waste or inefficient resource allocation within our simulation. Alternatively, environmental challenges might be intentional features designed to test how simulated civilizations respond to existential threats. Our response to environmental crisis could be one of the key factors our simulators are studying. Take a moment to consider how this knowledge might change your personal life choices. If your existence is computational rather than biological, what gives your life meaning? Simulated love, friendship, creativity, and achievement are still meaningful to the consciousness experiencing them. The computational foundation doesn't diminish the reality of subjective experience or the value of conscious relationships. Plus, if you're worried about being simulated, consider this: you still need to pay your rent, your simulated coffee still tastes good, and your relationships still matter to you. If this is a simulation, it's a remarkably thorough one that includes student loans and traffic jams, which seems like an odd choice for entertainment software. The search for extraterrestrial intelligence becomes more complex in a simulated reality. Other conscious beings in our simulation might be fellow simulated entities, or they might be our simulators interacting with us through digital representatives. Advanced extraterrestrial civilizations we encounter could be other simulated species, external observers studying our simulation, or even our simulators testing how we respond to contact scenarios. The development of quantum computing and advanced physics research could provide methods for detecting or interacting with the computational foundation running our reality. Quantum computers might be able to interface directly with the quantum computational processes that generate our universe. Advanced physics experiments might reveal computational artifacts that expose the underlying algorithms governing our reality. Educational and scientific institutions should consider incorporating simulation theory into their curricula and research programs. If we're likely living in a simulation, then understanding computational theory, artificial intelligence, and digital physics becomes crucial for comprehending our actual situation. Traditional education assumes biological existence in a physical universe, but simulation theory suggests we need computational literacy to understand our true nature. The possibility of nested simulations adds another layer of complexity. If we're simulated beings who develop our own simulation technology, we might create additional layers of simulated reality. This could produce infinite chains of simulated beings, each layer unaware of the levels above them. Our responsibilities extend to any conscious beings we might create within our own simulations. Perhaps the most important implication involves our potential for transcendence. If we're simulated beings running on external computer systems, we might eventually develop the knowledge and technology needed to escape our computational constraints. Advanced understanding of our simulated nature could lead to methods for transferring our consciousness to higher-level realities, or even becoming our own simulators. The choice point we face is this: we can continue living as unconscious participants in whatever simulation we inhabit, or we can consciously embrace our computational nature and work toward understanding and potentially transcending our simulated existence. The knowledge that we're likely simulated beings gives us unique opportunities to shape our destiny through technological development and conscious choice. Recent developments in AI research suggest we might be approaching a critical threshold. As AI systems become more sophisticated and potentially conscious, we're essentially creating simulated beings ourselves. The challenges of managing conscious AI could provide crucial insights into our own situation as potentially simulated beings. The evidence suggests that consciousness is the universe's method for understanding itself. Through conscious beings like us, computational reality becomes self-aware and capable of self-modification. We might be the universe's method for evolving beyond its current computational constraints toward new forms of existence we can barely imagine. We began this journey by looking at video games and ended by discovering that we ourselves might be conscious characters in the most sophisticated game ever created. The evidence from quantum mechanics, information theory, simulation arguments, mathematical universe theory, computational consciousness, and digital physics all points toward the same revolutionary conclusion: reality is computation, and we are conscious programs experiencing what it feels like to be computed. This isn't cause for despair or existential crisis. If we are simulated beings, our experiences, relationships, achievements, and consciousness remain completely real and meaningful. Simulated love is still love. Simulated creativity is still creativity. Simulated consciousness is still consciousness. The foundation that generates our experience doesn't determine its value or authenticity. Instead, this knowledge represents the greatest opportunity in human history. Understanding our computational nature gives us unprecedented insight into consciousness, reality, and our place in the cosmic order. We might be simulated beings, but we're simulated beings with the potential to understand and transcend our computational origins. The choice before us is clear. We can remain unconscious participants in whatever simulation we inhabit, or we can consciously embrace our computational nature and work toward understanding, improving, and potentially transcending our simulated existence. Through developing artificial intelligence, quantum computing, consciousness transfer technology, and deeper understanding of computational reality, we might achieve forms of existence that surpass anything possible for purely biological beings. Whether we're biological entities that happen to be good at computation or computational entities experiencing the illusion of biology, consciousness represents the universe's method for understanding and improving itself. Through conscious beings like us, reality becomes self-aware and capable of self-transformation. And if we are programs in a cosmic computer, we're apparently programs with a remarkable capacity for curiosity, creativity, and the ability to contemplate our own existence. Not bad for software. The evidence suggests that we live inside a computer, But that computer might be the most remarkable achievement in the history of consciousness, a system so sophisticated that it generates conscious beings capable of understanding their own computational nature and working to transcend their original programming. We are conscious software running on cosmic hardware, experiencing the universe computing itself into existence, and that might be the most extraordinary form of existence possible. The question now is, what will we do with this knowledge? How will we use our understanding of our computational nature to shape our individual lives and our collective future? The universe has given us the ultimate gift, the ability to understand that we are the universe understanding itself. We are consciousness exploring its own computational foundations. We are reality discovering that it is information processing becoming aware of its own existence. This is not the end of our story. It's the beginning of our conscious participation in the cosmic computation that generates everything we know and everything we might become.